I think the way to do this question is just to try and fit as many of these T-shaped shapes in, basically. So let's just give it a go. There's one. Because we're trying to fit as many in, it makes sense to put another one right next to it. And then we could put one down here. And then maybe one here. Now the thing is, you can see there's no way you could fit a fifth one in. We get this kind of Z going on. So it feels like just from a first attempt that the maximum is going to be 4. You could try again, you could say like, oh, maybe I just didn't do a very good job. The thing is, if you go with this, then there's absolutely no way that you can then fit a tease into this area over here. That's what I would argue. Because if you did this, then you're leaving um, that one like is going to be empty. And then if you kind of do this, you're going to leave that top right one empty. So it can't be in that orientation. But actually that then only leaves this orientation here. And then you kind of got to follow the process like here, here, you don't actually have any choice. And then again, we're into similar difficulties when you get, well, you've got to put one here. And then, yeah, you're back to a Z. So basically I've shown, for 2 different cases of how you could fit the T that there's no way you can get 5. So the answer is going to be 4. I'm not quite done. For our purposes, we're definitely done. And you could even maybe just after the first one convince yourself, yeah, that's it. That has got to be the most. For harder problems, when you get onto sort of Olympiads and things, then sometimes you have to prove why for certain that 5 are not possible. So I'm just gonna do my best at giving a brief explanation here of that, because it's a method actually that it just comes up so often, and that is to consider the grid as a chessboard essentially, alternatively shade in the squares black and white. So what we see if we put a T down, this is my T now, is actually it's going to go over 3 of the same color and 1 of the other color. So 3 black and 1 white for my case. And then if I do this, then I'd kind of balance it out. So the same number have now been used. And then maybe here, and then here like before. So, I've got to kind of balance them out. Otherwise, you can see there's no way that you could just use like 3 black squares every time. You're going to run out. So that takes us to the very last situation. And here we've got the equal number of black and white. So you can see there's no way you could fit a fifth one in, because for a fifth one, for a fifth, would need 3 black and 1 white, or vice versa. And if, let's say, for example, that purple one had been moved up one and was like here, then they'd all be white actually, which is again not possible, or they'd all be black if you kind of did it differently. So this is just a wordy reasoning of that. It's just meant to be kind of a bit of insight into how you deal with these kind of problems in harder questions where you properly have to prove why 4 is the maximum. For our purposes, I've kind of given an explanation up here, which I think was pretty decent, and then I've just talked a little bit about the chessboard here as well. So overall, 4 solutions. Nice job.